In this video, I will show you how to use the first derivative test to find all relative extrema. In other words, the local maxima or minima. I will also show you how to justify your answers. Let's go ahead and find the first derivative. So f prime equals, doing the power rule, negative 6x minus 4. In factored form, f prime is negative 2 times 3x plus 2. Now we can find the critical numbers. These are the values that cause f prime to either equal 0 or be undefined. But f prime is a polynomial, so there are no values that will cause it to be undefined. We can forget about that aspect of it. But where will f prime equal 0? Just set it equal to 0 and solve. So dividing by negative 2 on both sides, we have 3x plus 2 equals 0. Subtracting 2 and dividing by 3, we have x equals negative 2/3. So this is our one critical number, our only critical number. Let's put this critical number on a number line so we can make a sign chart. So here is negative 2/3. We have two factors to consider, so I'm going to make two rows here. Be sure to label your sign chart as f prime. I'm going to put negative 2 on its own row and then 3x plus 2. We need to figure out if these factors will be positive or negative in each interval. Well, negative 2 will always be negative, so we can just mark that off. For values of x that are less than negative 2/3, 3x plus 2 will be negative. For example, if x is negative 1, then you'd have 3 times negative 1, which would be negative 3, plus 2 would be negative 1. For values of x that are greater than negative 2/3, you're going to get a positive value. For example, if x is 0, then this term is gone and you are left with positive 2. Now we need to consider the overall value of f prime. A negative times a negative is a positive, and a negative times a positive is a negative. I'm hoping that a long time ago you learned the graphical relationship between f prime, and f double prime. For now, focus on the fact that if f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. So that means that the original function should be increasing in this interval from negative infinity to negative 2/3 and decreasing in this interval from negative 2/3 to infinity. So graphically that would look like this. If it's increasing and then decreasing, you can see that we must have a relative max at negative 2/3 because it's going up and then down. So we can say that if f prime goes from positive to negative, then we have a local max or a relative max. So here's how you would write your answer and justify. F of x is increasing from negative infinity to negative 2/3 because f prime is positive. F of x is decreasing from negative 2/3 to infinity because f prime is negative. F of x has a relative max at x equals negative 2/3 because f prime goes from positive to negative. For number 24, we will have to use the product rule. So this will be our first factor, and this will be the second factor. We will start off by taking the derivative of the first factor. So that 2 is going to come in the front. And we have this inner function of x plus 2. Normally we would now do the chain rule and multiply by the derivative of the inner function. But in this case that's just 1. So we don't need to write that down. So there's the derivative of the first factor. You leave the second factor alone. So I write x minus 1 and then plus. Now we go through it again. This time through, we leave the first factor alone. So I write x plus 2 squared. and then I multiply by the derivative of the second factor. But the derivative of x minus 1 is just 1, which I don't need to write. So this is the derivative, but we want to simplify this by factoring. Often when you do the chain rule, you're going to have certain factors repeat. In this case, notice that we have the x plus 2 here and here. So this is what we want to factor out. So we're going to put x plus 2 out in the front, and then let's figure out what will be left inside the parentheses. If we take away the x plus 2, the 2 is still there, and this x minus 1 is still here. Now, we've taken away one factor of x plus 2, but there were two of them, so there's still a factor of x plus 2 left behind. So now we have f prime equals x plus 2 times, and let's simplify this. So distributing the 2, we have 2x minus 2, and then x plus 2. So now we have f prime equals x plus 2. So 2x plus x is 3x. And then negative 2 plus 2 is 0. So they cancel each other out. So now we have this. So it's time to find the critical numbers. That's where f prime either equals 0 or the values that cause f prime to be undefined. But again, this is a polynomial, so there are no values that will cause f prime to be undefined. So where will f prime equal 0? In factored form, we can easily see that those values are x equals negative 2 from the first factor, and x equals 0 from the second factor. So these are the two critical numbers. We're going to put these on a number line and make a sign chart. So here are the critical numbers on the number line. We have two factors to consider, so we will need two rows on the sign chart. Make sure you label the sign chart as f prime. So we will need a row for x plus 2 and a row for the 3x. Now let's consider whether these factors will be positive or negative in each interval. So if you set x plus 2 equal to 0, you get negative 2. So this is the cutoff for this factor. For values of x that are less than negative 2, this factor will be negative. For example, if you pick negative 3 for x, that's negative 3 plus 2, which is negative 1. For values of x that are greater than negative 2, you will get a positive result. For example, if you let x be 0, then you just have positive 2. For 3x, it's easy to see that if x is negative, then you're going to have a negative value. So for values of x that are less than 0, 3x will be negative. If x is greater than 0, 3x will be positive. What about the overall value of f prime? A negative times a negative is a positive, and a positive times a negative is a negative, and a positive times a positive is a positive. So we have learned that if f prime is positive, then the original function will be increasing. So f of x should be increasing in this interval and in this interval. Because f prime is negative from negative 2 to 0, then f should be decreasing in this interval. So here's what we have so far. F of x is increasing from negative infinity to negative 2 and from 0 to infinity because f prime is positive. F of x is decreasing from negative 2 to 0 because f prime is negative. Now let's see if we can identify the extrema. Where will there be a relative max or a relative min? If f of x is increasing in this interval, and then decreasing in this interval, you can see that we have a relative max at -2. It's kind of at the top of a little hill. So we would say f of x has a relative max at x equals -2 because f prime goes from positive to negative. Similarly, if f of x is decreasing in this interval and increasing in this interval, that means there must be a relative minimum at 0. It's at the bottom of this valley. So we would say f of x has a relative min at x equals 0 because f prime goes from negative to positive. Ooh, let's see what happens when we have fractional exponents in the mix. So f prime, we're going to do the power rule, so this 2/3 will come to the front. We have to subtract 1 from this exponent, so think -3/3. So this will be the -1/3 power. The derivative of a constant is 0, so we write nothing for that. Because this is a negative exponent, I'm going to drop this down to the denominator. So we have f prime is equal to 2 over, well, there's your 2/3 right there. But now here is x to the 1/3 power. It's time to find the critical numbers. These are the values of x that will either cause f prime to equal 0 or to be undefined. A fraction will equal 0 only if the numerator is equal to 0. But in this case, the numerator is a constant, so there's no way for that to equal 0. So we can forget about this source of critical numbers. How about the values of x that will cause f prime to be undefined? Well, that's when the denominator is equal to 0. And if in this case, that will be if x itself is equal to 0. So we have one critical number to put on the number line to make a sign chart. So there is 0 sitting on your number line. We only need one row because the only factor we need to worry about is x to the 1/3 power. Make sure you label your sign chart as f prime. It's easy to see that for values of x that are less than 0, then x to the 1/3 power will be negative. For values of x that are greater than 0, x to the 1/3 power will be positive. That means that the original function will be decreasing in this interval and increasing in this interval. Let's write that down so far. So far we have f of x is increasing from 0 to infinity because f prime is positive. F of x is decreasing from -infinity to 0 because f prime is negative. In addition to that, we know that because f of x is decreasing and then increasing, there must be a relative min at x equals 0. Let's write that up. We say f of x has a relative min at x equals 0 because f prime goes from negative to positive. Notice in your justifications, they are all based on f prime. F prime is positive. F prime is negative. F prime goes from positive to negative. Make sure you are basing all of your justifications on f prime here. Aw shucks, we got trig functions, y'all. This is probably going to be next level. So here we go. Let's do the product rule. We will take the derivative of the first factor. The derivative of sine is cosine. We leave the second factor the way it is, cosine. And we put a plus and start over. The second time through, we leave the first factor alone. And we take the derivative of the second factor. The derivative of cosine is negative sine. But I'm going to take this negative sign and put it right there. The derivative of plus 5 is nothing, so we leave that blank. Of course, we will simplify this by writing cosine squared x minus sine squared x. Time to find the critical numbers that cause f prime to either equal 0 or be undefined. Sine and cosine are never undefined, no matter what the value of x is, so we don't have to worry about this part. But where will f prime equal 0? Well, let's set f prime equal to 0 and solve. This can be factored using the difference of squares. So we can write cosine x plus sine x times cosine x minus sine x. Now we can use the zero product property and set each one of these equal to 0. So we will have cosine x plus sine x equals 0, and we will have cosine x minus sine x equals 0. Subtracting sine x from both sides, we get cosine x is equal to negative sine x. And adding sine x to both sides for this one, we get cosine x is equal to sine x. So now we just have to solve these two little equations. Focus on the red equation first. Cosine x equals sine x. I like to solve this equation mentally by thinking to myself, the only time that sine and cosine are going to be equal is if the reference angle is pi over 4. At pi over 4, the cosine and sine are both the same because they are both radical 2 over 2. In the third quadrant, the angle that has a reference angle of pi over 4 is 5 pi over 4. And here again, sine and cosine are equal, this time because they are both negative radical 2 over 2. So these are the two solutions to this red equation. We can find solutions to the green equation in a similar way. This means that we need sine and cosine to be equal to each other, except for one should be positive and one should be negative. We're still talking about a reference angle of pi over 4, but this time we must be talking about the second quadrant and the fourth quadrant. Think about it. In these quadrants, the x value and the y value have opposite signs. Specifically, in the second quadrant, cosine is negative radical 2 over 2, and sine is positive radical 2 over 2. In the fourth quadrant, cosine is positive and sine is negative. So we have just what we're looking for. Cosine and sine are equal in value, except for one is positive and one's negative. So 3 pi over 4 and 7 pi over 4 are the solutions to the green equation. So we have 4 critical numbers to put on our number line. Keep in mind that we are limiting the number line to between 0 and 2 pi. Make sure you label your sign chart as f prime. Here are those two factors that make up f prime. It's time to check each factor to see whether it is positive or negative in each one of these intervals. Let's start with the green factor. We are allowed to use 0 itself for this first interval. So if we do cosine 0 plus sine 0, cosine of 0 is 1, and sine of 0 is 0, right? Because cosine is the x value, sine is the y value. So that is 1, but what really matters is that it is positive. Between pi over 4 and 3 pi over 4 is pi over 2. So let's do pi over 2. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So that is still going to be positive. Between 3 pi over 4 and 5 pi over 4 is pi. Cosine of pi is negative 1, and sine of pi is 0. So this value is going to be negative. Between 5 pi over 4 and 7 pi over 4 is 3 pi over 2. The cosine of 3 pi over 2 is 0 because the x value is 0. The sine of 3 pi over 2 is negative 1 because the y value is negative 1. But that's going to have a value of negative 1, so this is negative. For this last interval between 7 pi over 4 and 2 pi, it's okay to use 2 pi. I'm using 0 and 2 pi, by the way, because these are included in the interval, so they're allowed. But the cosine of 2 pi is 1, and the sine of 2 pi is 0. So this is positive. Let's do the same thing for the red factor. For the first interval, we can just use 0 itself. So cosine 0 minus sine 0. Cosine of 0 is 1 minus the sine of 0, which is 0. That's going to give us a positive. Between pi over 4 and 3 pi over 4 is pi over 2. Cosine of pi over 2 is 0, and sine of pi over 2 is 1. This will give us negative 1, so we have a negative interval. Between 3 pi over 4 and 5 pi over 4 is pi, but cosine of pi is negative 1, and sine of pi is 0. Negative 1 minus 0 is negative 1, so we have a negative value. Between 5 pi over 4 and 7 pi over 4 is 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. Minus negative 1. So that's actually positive 1. So we have a positive value. For this last interval from 7 pi over 4 to 2 pi, we can go ahead and just use 2 pi. Cosine of 2 pi is 1. Sine of 2 pi is 0. So that is positive 1, a positive value. So that means the overall value of f of x is going to be positive in this interval, because a positive times a positive. Negative in this interval, positive times negative. Positive again in this interval, negative times a negative is a positive. Negative in this interval, and positive in this interval. But let's translate that into the behavior of the original function f of x. That means f of x is increasing in this interval and then decreasing in this interval. Increasing and decreasing and increasing. So let's write down everything we just said. So we can say with a deep breath, f of x is increasing from 0 to pi over 4 and 3 pi over 4 to 5 pi over 4 and from 7 pi over 4 to 2 pi because f prime is positive. F of x is decreasing from pi over 4 to 3 pi over 4 and from 5 pi over 4 to 7 pi over 4 because f prime is negative. Also, we can talk about the relative extrema. Because of the way f of x is increasing and then decreasing, we know there will be a relative max here. It goes from decreasing to increasing here, so this will be a relative min. Increasing, decreasing, relative max. Decreasing to increasing, this will be a relative min. But be careful, when we write this up, I'm not going to say anything about increasing and decreasing. We have to base our justifications on f prime. So I'm going to say, for example, we have a relative max at pi over 4 because f prime goes from positive to negative, not because f of x goes from increasing to decreasing. So we will say f of x has a relative max at x equals pi over 4 and x equals 5 pi over 4 because f prime goes from positive to negative. F of x has a relative min at x equals 3 pi over 4 and x equals 7 pi over 4 because f prime goes from negative to positive.